Hello and welcome to our video on computer hardware. In this video, I just want to go over some of the basics of computer hardware so that you're familiar with some of the terms that we'll be using throughout the semester. And as you can see, these are not my slides. These are some that I borrowed from a colleague of mine here in the Department of Computing Sciences, Dr. Mike Murphy. Okay, so what are the components of a computing device? What are we going to find in a computer? Well, of course, we're going to find a case, right? That's the outside thing that we look at. We're going to also need a power supply, some way to power up all of these components that we're going to put inside that case. We're going to need a motherboard. That's a very important component. Without the motherboard, or arguably without any of this stuff, the computer would not run. But the motherboard is what ties all of these different chips that we plug into it together. The CPU can be thought of as the brain of the computer, so that's our central processing unit, and that's where everything actually gets processed, or the instructions get executed on that CPU. Next we have RAM, and RAM is randomly accessed memory. So this is where, as we're executing instructions and we're storing things, or we're storing program code or instructions to be ran, they're going to be stored in RAM. Okay, so we'll talk a little bit more about these things as we progress through the lecture today. Persistent storage, so we need some way to store things when the computer turns off. RAM is not a good place for that. RAM is known as volatile memory, which means it needs power in order to store something. So once we turn a computer off, or we put it, when we turn a computer off, what's stored in RAM goes away. It dissipates out of memory very quickly, and it's gone. So we need something else to store our long-term memory, our programs, our Word documents, our Excel spreadsheets, etc. And we do that in persistent storage. Lastly, we're going to need some other things, some other peripherals like network adapters so that we can access the network, video adapters so that we can display things on monitors, and then of course some other hardware like mice and keyboards. Okay, so the case. What is the purpose of this? It keeps all of the components together. It shields them from outside electrical interference, sometimes dust, although we'll see that dust builds up from being dragged in by the fans. And it also directs airflow around inside. So we need to direct airflow so that we can cool down some of these components that run really hot, like the CPU or graphics cards. Cases come in many different sizes or form factors. So they're have specific meanings like ATX, UATX, Mini ITX, USFF. We have rack mount cases, and we have laptops. So, and then of course also sort of unconventionally here we have mobile devices like tablets and cell phones. They have cases as well. We have a typical what looks like a desktop server here. It looks like a desktop, but it's server hardware. We also find server hardware in these rack mount servers. They look kind of like pizza boxes. Sometimes they're called pizza box servers because it's what they look like. And then we have a laptop here that we're probably all familiar with, laptop cases. So power supplies are very important. What they do is their main functionality is to take in AC power from an electrical plug and then to output that into low voltage DC power that the components can use. So the components that we use inside our computer do not run on AC power, they run on DC, and that's why we need this power supply. Here's a picture of what one looks like for an internal power supply for a desktop. It's typically a little box like this, and it's got a bunch of wires coming out of one end that have different connectors that we can plug in to power up our components on the motherboard. On the other side, it'll just have your typical wall outlet plug coming in and plugging into the back of it. Okay, so there's two different types, right? There's internal power supplies like we see here, but then there's also external power supplies. How does our laptop get power? Obviously we are, oops, sorry about that, let me jump back here. Obviously we're taking power out of the wall and we're plugging that cord into our laptop, so something there is changing it from AC to DC power, and it's usually that power brick, that little brick that lays in line between the wall and the laptop. For mobile phones, that would be the little wall wart that you plug on the wall. There's usually, when you buy a cell phone, you get a little small plug that plugs into an AC outlet, and then usually a USB cord will plug into that. Well, that little plug that we plug into the outlet, its responsibility is to convert AC power to DC. Okay, so the motherboard, sometimes called the logic board. This is the main circuit board to which all internal components connect. So it's got all sorts of slots, sockets, ports, and onboard controllers. Some things are built into the motherboard, some things aren't, and we have to plug them in. Okay, so lots of times a motherboard will already have ports and plugs for USB. It'll have USB controllers already on it. It might have Thunderbolt controllers or HDMI controllers, VGA, so that we can plug in different sort of peripheral hardware. And for what it doesn't, we have to buy things and plug into this motherboard. So we can see like the CPU would go here. We need to be able to put a CPU on there. Maybe I think this might actually be the CPU because we have the fan and the heatsink on top of this. Let's see. So moving into the CPU here, this is the chip that actually runs the computer. As I mentioned earlier, this is where the instructions are actually executed. And it's kind of hard to believe that one of the most important parts of the computer is so tiny. I mean, it is very tiny. It's the size of like a $50 if you look at one. So this executes software instructions, specifically machine instructions. Okay, so and it attaches to the motherboard using pins or slots. It usually goes on there, and then we'll put something on top of that because this generates a lot of heat. So that's what I was talking about here. Is it looks like we have a heat sink, which would just be like a piece of metal that can take that heat and disperse it. And we see it disperses it sort of this way, and we got a fan that blows on that as well to sort of knock some of that heat off. Alright, so usually we can just sort of plug these in and remove them. On some devices, they're actually going to be soldered on there, like embedded devices or like newer MacBooks and MacBook Pros. I believe they've started soldering the CPU on. If not the CPU, definitely they're soldering the RAM in so that you can't just easily go in there and upgrade it. Speaking of RAM, this is what RAM looks like. There's many different sizes and speeds of RAM. So if you're going to buy RAM for your computer, you're going to want to make sure that your motherboard supports it. RAM is short-term data storage. So I mentioned earlier that this is volatile, meaning that when the power is turned off, everything that's in it dissipates and it forgets what was stored. It is relatively fast though. It is faster than, let's say, our conventional hard disk drive or even our solid state drives. It's an order of magnitude faster than that. So it's preferable to have as much RAM as possible because this is where our programs are going to get loaded up when we go to run them, and then the instructions are going to get fetched from this RAM and moved into the CPU so that the CPU can execute them. Persistent storage, though, also equally important because we need a place to store these programs. We don't want to have to recreate them each time we turn the computer on, and obviously the operating system has to reside somewhere, so we need a form of long-term storage. So being long-term, it's going to be non-volatile, which means when we turn the power off, the data stays in the hard drive. This is relatively slow. It's an order of magnitude slower than RAM, which is also an order of magnitude slower than the little bit of memory that we have in a CPU. So we have different levels of memory here. Obviously this is the slowest, but it's very important because we need to keep that stuff somewhere. There's many different types of hard disk drives. So conventionally we have mechanical hard drives, and we call these mechanical because there are spinning, moving parts inside of them. This right here is actually the hard drive, and it's usually platters stacked up on top of each other. And then it has a read-write head that comes out similar to a CD, and it just moves around on here as this thing is spinning, and it reads data off of it. Again, this is a very slow process, and there's different speeds. I don't know, can we see the speed on this one? It looks like it's 5,400 RPMs, there's 7,200 RPMs, there's 11,000 something RPMs, and then after that we get into solid state drives. So this is sort of the evolution of persistent storage. A lot of computers nowadays are starting to come with solid state drives or some hybrid between solid state and mechanical hard drives. What's the advantage of it though? It's non-mechanical. It stores the data electronically inside flash memory cells, similar to like a flash drive when we plug that in. Although it's much faster than a flash drive, and it's also much faster than a mechanical hard drive, but do note that it is slower than RAM. So although it is faster and we will definitely notice in performance increases, it is not at the speed of RAM. And the reason being is RAM is just still very expensive. We can get a half terabyte SSD way cheaper than we can get a half terabyte of RAM. That would be prohibitively expensive, and we also wouldn't have the connections in order to do that on most consumer-based motherboards. Okay, so video card. Lots of times this, what shows us the video is being wrapped into the CPU and combined with the motherboard, but sometimes, and especially for gamers or other unique applications like mining or password cracking, we'll want to have a video card. This is specialized hardware. It has its own dedicated RAM and its own dedicated cores that it works on data. And it's optimized for rendering images, but it also performs certain mathematical operations that lend itself well to other things, like I mentioned, password cracking or mining for cryptocurrency, something like that. Okay, so this can be integrated into the motherboard, or it can be discrete in that it's its own little card here that plugs into an interface on the motherboard. Network adapters are the same way. These guys, typically nowadays you get at least one integrated onto the motherboard, soldered in, it just comes part of it. And it enables computers to talk to one another. So this is probably the majority of what we do on a computer now, right? We use the internet. Now we store things on the internet in the cloud, so we need access somehow. There's different types of network cards. So this one is one that would plug in with like a Cat5, Cat6 Ethernet cable. More commonly, what we're going to find, especially in laptops, is going to be a wireless Ethernet card or a wireless network card. So we can see what one of these looks like here. This one's out of a laptop, and if you open up your laptop, you can usually see where one of these are without taking too much apart. Alright, so there's always other devices that we can put on. We can add FireWire connections or Thunderbolt connections via different cards similar to the graphics card there, but these were the main components that we need to run a computer. We can also attach external devices via some of these connections and other buses that we have, like USB or FireWire or Thunderbolt, and those would be external devices that are used by our computer. In fact, you can actually buy external video cards now thanks to the speed and the bandwidth that we can get with Thunderbolt connections. Alright, so I hope you enjoyed the lecture. I hope you learned something. If you have any questions, please feel free to reach out to me. If not, I'll see you guys in the next video. Thank you.